Today we're going to talk about Unit 1, Lesson 1, what are scaled copies. So our learning targets, or what I'm expecting you to know by the end, is that you can describe some characteristics of a scaled copy and that you can tell whether or not a figure is a scaled copy of another figure. So our first activity is printed portraits. So we're looking at this original portrait, which is up top. And then we're comparing it to A, B, C, D, and E. So I'm going to use the applet for this part. So I'm going to click back and then I'm going to click open for my link because I want to compare them. So I'm going to go back and look at my questions. It said some of the portraits are scaled copies of the original portrait. Which ones do you think are scaled copies? Explain your reasoning. So I'm going to go back to my applet and I'm going to look. So there's my original portrait. So as I move the thing, okay, that looks like it's pretty even, but as I shrink it, his features get smaller, but he stays the same height. Does that make sense? Like his features shrink? Okay, if I look at B, well, if I pull it all the way over, he looks the same height, but as I toggle it over, he actually shrinks, but his features are still just as wide. So when I pull this one, he's the same size. And as I shrink it, all of his features shrink at the same rate. They seem to all get small at the same rate. D, same thing. It's all the features shrink at the same rate. This one, he becomes more slanted. Well, if I pull it back, he becomes more straight. So I think C and D are the scaled copies because they go up and down with all the features. So it says, which ones do you think are scaled copies? So I think C and D are scaled copies because the features grow at the same rate, grow and shrink. In 6th grade, we talked about rate, and we talked about how it was a proportional thing, how it was a ratio between two numbers. We're going to kind of go back to that with this unit. So what do you think a scaled copy is? I think it's a smaller or larger version of the original. So, for example, this one is a larger version of this one, and this is a smaller version of this one. Whereas these, they're not exactly the same picture because the head is either fatter or thinner or at a diagonal. So for this next one, we're looking at the drawings. Examine all the scaled copies more closely, specifically the length of each part of letter F. So my original is 2 on the top, 4 on the side, 1. So I filled that in for you. So 2, 1, 4. I'm going to do the same thing with all the others. So I count, so it's 3, 1.5, 1, 2, 3, 4, 5, 6. So it's 3, 1.5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So it's 4, 2, 8. The next one is 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So it's 4, 3, 4. The next one, well, this one's kind of on a slant, so it's 2, and then I'm not really sure, it's 1-ish. So I'm not really sure because it's not quite one whole box. And then I've got 1, 2, 3, 4, but I'm not really sure if it's 4 boxes because it's not perpendicular, it's not straight up and down. So I'm gonna say 2, 1, and I'm gonna put an ish right here. So ISH, because I'm not really sure, I'm not exactly positive. So, and then drawing the side length is 4-ish, I'm not exactly sure. This one, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 6. So I have 3, 2, 6. The next one is 1, 1, 1, 2. So it's 1, 1, 2. And then the last one's a really big one, so it's 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 6, 3, 12. So how do they compare to the original? So remember, when you're talking about the original, we're looking at those original measurements I gave you. So 2, 1, 4. So how do they compare? Well, when I look at drawing 4, I see that they have the same top but different middle and side. So if I was going to say, what do I notice? 4 has the same length top, but different side and middle lengths. So that one didn't grow at the same rate. It didn't grow all the parts together. Okay, if I look at the middle length for drawing 6, same kind of thing. So I could add 4 and 6. And then if I look at drawing 3, it's the same way because they have the same side length, but that doesn't work. So I know that 3, 4, and 6 are not scaled copies. So now I'm going to look at the other ones and see if I can kind of see a connection. Well, I know that doubling, if I double 1, I get 2. If I double 2, I get 4. If I double 4, I get 8. So I think 2 is a scaled copy. Because it's growing at the same rate all the way across. If I look at drawing 7, 2 times 3 is 6, 1 times 3 is 3, 4 times 3 is 12. Again, I think it's a scaled copy because they grow at the same rate. Now my question is these other ones. So the middle length of, if I look at drawing 5, for example, 1 times 2 is 2, but 2 times 2 is not 3. So 5 is out because they didn't grow at the same rate. So they didn't grow by the same multiple. Okay, then I want to look at drawing number 1. So I have to think, what did they multiply it by? So they multiplied it by 1.5. So I would actually have to get out my calculator and do, because 1 times 1.5 would give me 1.5. So 2 times 1.5 is 3, and 4 times 1.5 is 6. So scale drawing 1 is a scaled copy as well. It's kind of a hidden one. I wrote the wrong number there. This should have said 7. So when I look at it, those are what I notice. So then it says, identify all the drawings that are scaled copies of the original letter F and explain how you know. Well, we kind of did that in the last question. We said 1, 2, and 7. So 1, 2, and 7 are scaled copies, and we know they used the same rate to multiply all the lengths of the letter F. So the first one, for example, we figured out number 1, they used a rate of 1.5. For the second one, they used a rate of 2. And for the third one, they used a rate of 3. So they multiplied it by that number. So they're using that multiplier or that multiple. So they were all multiplied by the same multiple. Now this one, it's got an interesting part because this says in class only activity. So if we were in class where we're face to face, you would do this slide. But because you're not in class face to face, we're going to skip this slide and we're going to move on. And you're going to do the same activity again, but you're going to do a drag and drop instead. So I'm going to turn off my drawing tool and I'm going to look at the directions. So it says drag and drop pairs of polygons that are scaled copies of one another. So I want to drag and drop my scaled copies. So in this case, I want to think, okay, it's got to be multiplied by the same size. So this is, I'm actually going to turn my drawing tool back on. So this is 1, 2, 3. This is a 1, and this is, and these are each 1, and this looks like a 2.5. All right, so this is 1, 2, 3, 4, 5, 6, and this is a 2, and this is a 1, and this is 1, 2, 3, 4, 5, 6. So when I look at it, I see 3 times 2 is 6, 1 times 2 is 2, but 2.5 is not 6. So those two are not a pair yet. So I'm going to keep going. 1, 2, 3, 4, 5, 6. 2, 2, 1, 2, 3, 4, 5, 2. Okay, so if I look at this, 3 times 2 is 6, 1 times 2 is 2, 1 times 2 is 2, 2.5 times 2 is 5. So these two are a scaled copy.